So let this be 2 kg block. Let this be 3 kg. I'll connect them by a string. This is a rough surface. Let mu equal to 0.2. I'm going to apply force. So let me put a variable forces here, F1, and this will be okay, clear this one. So we are just going to learn. You see that already we know enough concepts. There's nothing, we know enough concepts. So first we'll calculate the limiting frictions. First we'll have the values of limiting friction. So what is the limiting friction? F1L here, this will be N1 and this will be 3G. There's a mass of the block, M1, I'll write it. Let this be M2. Here N2, this will be 2G. So what is the F1L? It should be equal to mu into N1, 0.2 into 3G. So this should be equal to 6 Newton. Limiting friction. Similarly, F2L is equal to mu into N2, 0.2. What is this? 2G. This will be 4 Newton. So whenever you enter into the problem, no, have that limiting frictions in hand. We have to calculate. Okay, let's discuss the first case. The first case, F1, I'll apply 3 Newton. This I'll apply 1 Newton. So what I'm going to ask you, find the tension and the frictional force acting on the block for the various values of F. Find the tension in the string and friction acting on the block for various values of F1 and F2.
Sir, friction acting on which block, sir?
Both the blocks, no? Find the tension in the string and friction acting on the block for various values of F1 and F2. First, you see that the problem, what happened, you must be ready with the limiting friction. Then only you can say whether the block will shift or not. First case I give, F1 equal to 3 Newton, F2 equal to 1 Newton. So let me check it now. So I applied here 3 Newton. For the block, 3 kg block, for it to shift, what is the value of F needed? What is the value of force needed?
6 Newton.
6 Newton is needed. The value of force needed is 6 Newton. But how much we applied force? 3 Newton. So what friction will act here? Definitely static friction. Here I'll show it is a static friction. Got it now? So how much that static friction F1 should be? Equal to 3 Newton. Please don't repeat, don't repeat. Let me explain the problem. Most of them, they want to learn. Please, if you know it, happily you observe, no, why to repeat things? For everyone convenient, because everyone wants to learn here. Please, if you know information, okay, just be happy, no, why to repeat things? F1 is equal to how much here? The first case, F1 will be equal to 3 Newton. How do you can say? It's like I applied a force. What is the applied force? 3 Newton. Is it greater than limiting friction? No, less than limiting friction. So what is the nature of friction? Will be static here. So here, then F1 will be 3 Newton. So I'll write it static. Then come for this. What about the tension? Any tension will act? No tension. Because when the tension will act, when the block 3 kg shifts, then only tension will act. So no tension will act here. Then let's come for here. We applied 1 Newton force. Then here to shift the block 2 kg minimum, how much needed? 4 Newton. But what is the applied force? 1 Newton. So therefore, what is the friction acting here will be static here. So how much it should be equal to 1 Newton. I'll write it here only. The friction acting here will be 3 Newton. So what about the tension? The tension will be in fact 0. and the tension will be 0. F2 will be 1 Newton, tension will be 0. So I will take the second situation. Let F1 equal to, let me make it 3 Newton, I made it, no? Let me make it 7 Newton. F2 is equal to 2 Newton. We'll see what will happen to the blocks in this case. See, I do like interaction. So when you ask doubt, it will be much beneficial rather than repeating answers. So when teacher somewhere calculation goes wrong or some wrong idea he puts, it's very good. Students should really interact. But just repeating the content will not help anybody. That's what I feel. Because in schools you were taught to recite things, to repeat things, no, that try to avoid. In college, all such things will not work out. Slowly, I think you got habituated, but at least control that habit. So first I suggest you keep your hand from mobile. Put effort on the notebook, pen.
Sir, F static is equal to F kinetic over here, sir.
F static equal to, mu s equal to mu k. Mu s equal to mu k. Most of the problems we assume like that. Say actually 2, 3, 4, 5% when they repeat, no, it'll be very online teaching, hearing at a time 3, 4, 5%. That time I'm wearing microphones, so I'll get sometimes pain in ear. No, we do have a lot of technical problems. Please do understand. Not only you, I think many who are wearing headphones, no, it'll be very irritating to hear more than one voice. Many students, they have sent messages for me in WhatsApp. So like it's many students are repeating things. Ask them to not to repeat. Class belongs to everyone. Please do control your emotions. Okay, there's a 7 Newton force is there. Okay, let's check that one. So what is this applied force greater than limiting friction? So the block will shift. The block is about to shift. So therefore the friction acting will be a limiting friction. Show like this here. This will be F1L. How much? 6 Newton force. That how much was the force was 7 Newton. All other forces will be there. It's not that they will not act, will be there. M1G. What about the tension, the string? So what is the state of block? Block will be at rest. The reason for that, because the string is there, the string is there. So 7 Newton we applied. 6 Newton is utilized to overcome the friction. So the remaining tension, what happened? 1 Newton will be set up. Okay, let's come for this. Here 1 Newton force is there. Tension should always act away from the body. Now 2 Newton, here 1 Newton is there. So how much the limiting friction that should act here should be equal to static friction only, yet still it is. So F2 it is. So previous problem also 1 Newton, now also 1 Newton. Yes, it is. The tension, what happened here, the 2 Newton is applied. When the block M2 will shift, when the applied force is, so something the resultant force on it should be more than 4 Newton. No? So 2 Newton is there. In that 1 Newton, I should balance it. Now you can ask, tension was 0, no. Previous case tension was 0. Previous case tension is 0. Tension the string is 0.
Sir? Sir, when we don't know the direction of motion, how can we decide the direction of friction, sir?
What do you mean by we don't know direction of motion? I apply 7 Newton. 7 Newton greater than limiting. So the block M1 will try to shift towards right. And look at this one. 7 Newton here. 7 Newton. And here 2 Newton. So what is the resultant force acting on it? The applied force will be 5 Newton. But how much of limiting friction we have total? 8 Newton. So is that 5 Newton, can it overcome the 8 Newton? Not possible. So altogether what will happen here? So the blocks will not shift, that much I know it.
Sir, what happens when F2 becomes 6 Newton?
I'll give all the cases. I'll give all the cases. First, this is okay. Now you ask question,
Okay.
sir. What happens if students start from 2 Newton? Okay, you do one thing, no problem. 2 Newton I applied. Then sir, no tension. Here 2 Newton will add. Then tension 0. Then here 7 Newton. So then this block will shift. This will not shift possible because they're connected by string. They should have common acceleration. String should be tau. So therefore here what will happen is, so then one which is larger force, from there you have to analyze the problem, not from the smaller force. Here 2 Newton, here friction will be 2 Newton. Tension will be 0. If tension 0, 7 Newton is acting, 6 Newton, then this will accelerate, no? Is it possible to have a situation, this will accelerate, this will be attached? Not possible, no?
Okay.
Really, you are supposed to analyze here. Without analysis, is not possible. Got this? So now let me make third case. Say like this, you can just pick up the various values. As you change the values, the things will be totally different. So let me keep 7 Newton as it is. I will make F2 5 Newton. Third case. What are the F1 values? So we'll have this F1 value. 6 Newton. Limiting friction. 4 Newton. I'm going to slide down. What is the force acting? This will be 7 Newton. F2 5 Newton, and their blocks are kept on rough surface. Okay, now let's check it. How do this is M1, the normal reaction, weight M1G, normal reaction M2, the weight M2G. I'll start with the larger force. So here 7 Newton force is applied. See one thing, the best thing is like you come together. What is the net applied force? 7 Newton, 5 Newton. So the resultant force, how much will be? Only 2 Newton towards side. That 2 Newton, can it overcome 8 Newton? Not possible. No? So what do you expect the block? Block will be attached. The simple way of analyzing this one. So here the friction acting will be F1L. How much it is? 6 Newton. Then the tension will be 1 Newton. Let's come for here. So 1 Newton tension, if I bring it. So how much we have here? 5 Newton. 1 Newton tension is there. So remaining how much will be? Here, this will be the 4 Newton will act here. So limiting friction will come. On this side, will if you apply larger force, then we'll see, because I made this larger force. No, let's apply the larger force on the left block. Any values. It's not that we should always take this lower value F2. So I'll go for like this. 4 Newton. F2, let it be 8 Newton. Same, the limiting frictions, 6 Newton, 4 Newton. So there's unlimited like this. You can keep on assume different values and try to check what conditions will arise. There's the last case. I'll stop it. Other things you are supposed to work out. So this is the ground. friction net value, don't talk per. It's a very stupid thinking. I should use word stupid thinking. Net friction, sir. Net friction. Don't talk net friction. We are discussing the shift in the individual block. Say whatever you think is not science. Okay, it's good to think whatever you want, but at least some minimum, the basic science should be there when you're thinking. Do practice slowly now. So this applied force 4 Newton. So this is a normal reaction. This will be the friction. So I applied larger force acting on the block M2. No? So therefore this will be how much? This will be F2L 4 Newton I applied. Then how much tension will be here? 4 Newton. So here 4 Newton tension. Then will there be any friction? No friction here. Now students may start like this, the same problem. This M1, this M2. I applied a force 4 Newton. So why don't you start directly as a 4 Newton you applied? Then the friction acting here, let it be static friction. 4 Newton. Then the tension will be 0. Because when the string will be taut, when the applied force is more than limiting friction, 6 Newton. So tension will not be there. Then how much we applied here? The force applied here is 8 Newton. So is it possible? So and what is limiting friction here? 4 Newton. So the remaining 4 Newton will come here. So is it justified doing like this? I think this will be totally wrong, no? Always you have to start with what, like the larger force on the block where the larger force is acting. From there you have to analyze the things. So this will be wrong. So definitely here I apply 8 Newton, that will overcome the limiting friction. So the block is about to shift, string will become taut. So 4 Newton is acting. So coming from right hand side, again in this problem will be a headache here. No? 4 Newton applied, sir, here friction will be static, 4 Newton, no tension. What about here, look at the left block. So this will be totally wrong analysis. No? So therefore, so the larger force, the block on which larger force is acting, no, from there you have to analyze the condition. The wrong one, I'll take it out. Huh? Okay, to choose different values and learn. Huh? There's no fun. 1, 2, 3 cases, okay. Like this 10, 15 cases, teacher cannot explain. You are supposed to assume the different values and analyze the situation. Got it, no?